Guys, did you guys watch the Mayweather-Pacquiao fight?
I'm a lover, not a fighter.
Okay, and yo, what about you?
What's up? Watch the fight?
Hey, do you think Dr. Plickus is coming to the lab meeting today?
Well, I'm really excited to learn, so I really hope so. You think Fleek is coming in today?
He's probably still late because he's getting his hair done at the salon.
Look at the flick of that wrist. 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 Look at the flick of that wrist.
Good morning, ladies and gentlemen. Hope you guys didn't party too hard over the weekend. We have a lot of work to do. Alright, my young Padawans, we're going to be embarking on a new project. I've been really busy lately and we haven't published, so I'm going to need your all help. I'm assuming you guys are all familiar with Scnt?
Oh, you mean TMNT? Love that show, bro. Love that show.
No, it's somatic cell nuclear transfer. It's when you combine an enucleated oocyte with the somatic cell nucleus to make stem cells. Right, Dr. Plickus?
Correct. So here's a brief overview. We transfer a somatic cell nucleus, such as from a fibroblast, into an enucleated oocyte. During incubation, if all goes to plan, factors in the oocyte's cytoplasm will reprogram the somatic cell nucleus into an embryonic-like undifferentiated state. This requires resetting many epigenetic changes, including DNA, methylation, and histone modifications before embryonic gene transcription can begin. We can then electrically stimulate the cell to divide, and the cloned embryo can be used to produce patient-specific pluripotent cells for use in therapy or research. So far, using Scnt to produce human embryonic stem cell lines has proved very challenging and inefficient. The Tachibana group has successfully done this with infant and fetal somatic cells, but no one has been able to do so with adult cells. Any ideas as to why this might be more difficult with adult somatic cells?
Maybe epigenetic modifications are further removed from the embryonic state in adult somatic cells.
Maybe DNA damage and shorter telomeres?
Because they're like old?
Alright, I'm going to split you guys into two groups. It's up to you whether you want to follow the Tachibana protocol or modify it to get better results using adult somatic cells.
Okay. So, hey, do you want to work together on this?
Yeah, sure. I printed out this paper. This paper by Chung looks pretty good. Like,
Okay.
talks about somatic cell nuclear transfer. And
Hey, dude, one of you guys like want to be in my group?
So you're saying let's.
we can modify the
Okay.
protocol.
One eternity later.
Alright, so tell me what you guys accomplished. Did you make any modifications to the Tachibana protocol?
Alright, I kept it real, and I stuck to the OG plan my boy Tachibana came up with, and out of the 49 trials, actually 3 of my oocytes became blastocysts. However, only one of them formed a stable ESC line. And when I was doing genetic testing, I realized it was actually a tetraploid, which kind of sucks, so maybe I messed up in the, the enucleation of the oocyte or something, but whatever's got a stable ESC line. What up?
Alright, that's a good effort, but not good enough. How about you guys? What did you find?
We tried a modified protocol. We increased the incubation time for before activation to 2 hours instead of the standard 30 minutes. We were hoping that this prolonged activation time may actually provide some extra time for reprogramming prior to the start of embryonic gene transcription.
Yeah, we used somatic nuclei from 2 adult groups, one from a 35-year-old and one from a 75-year-old. We were able to develop 5 blastocysts, 2 of which developed into stable ESC lines, one from each adult group.
That's a clever idea. Any interesting observations?
So yeah, we did. We actually observed that the 5 developed blastocysts originated from the same oocyte donors regardless of the 30-minute or 2-hour incubation period.
Well, did you guys even check for diplokaryotype or what?
Yeah, we did. We also tested for the presence of pluripotent markers.
Good work, guys. So tell me how you confirmed that the genotypes were correct.
We used 16 short tandem repeat markers spread out on different chromosomes to confirm the genotypes matched the somatic cell nuclear donor and were different from the oocyte donor. We also verified that the mitochondrial genome matched that of the oocyte donor using 3 single nucleotide polymorphism sites, confirming that the cytoplasm came from the oocyte donor.
Were you also able to demonstrate pluripotency and self-renewal?
We checked for the expression of major pluripotency markers and confirmed that these markers were not present in the somatic donor nuclei before the reprogramming period. We conducted RT-PCR to check for all 3 germ layers after allowing the colonies to spontaneously differentiate. The formation of teratomas also supported development of these germ layers. Then, when we subjected the colonies to cryopreservation, the survival of about 60% of the colonies displayed self-renewal by fully recovering on mouse fibroblast medium.
Awesome, these are some major results. Your guys' ingenuity to adjust the incubation period allowed us to generate Scnt embryonic stem cells using adult nuclear donors, which has much greater clinical applications to regenerative medicine and disease research. Looks like we're going to get published. Good work.
Nice. I'm finally gonna get published.
Not you. All you did is give me tetraploid junk.
Oh. Okay.
Look at the flick of that wrist. Look at the flick of that wrist.